Buffalo Trace or something.
You need 24 credits.
Something that's hard to come by, right?
It's just for us.
Let him slide over so you can see.
Sure.
Sit behind the post.
You ready?
Right back there, maybe walk in, but I don't know where your schedule
Sound.
That's all I need. Good to go. Ready to go?
One of the guys who used to work at Winston, called Polycode.
So you, okay? Okay.
It's Johnny.
Okay, guys, good to have you back with us. As you can see, we've got a full house today, and we're delighted to pack you guys in here. We had to rearrange the furniture a little bit, so if you forgot to sign in, the sign-in sheet's actually in the foyer there. So don't forget to sign in. And I'm going to have Ken Garrison is the executive director of HCCA, and I'm going to have him introduce our panelists today. So I'm going to turn things over to Ken. Thank you very much.
Okay. Thank you all for joining us. And I will be introducing the panel and then getting out of the way because these are the experts up here to talk. But what we've tried to do is talk about the constructability of plans. And we've put together a panel of 4 of the experts in the field, but from just slightly different bent. They all work together at one time or another for a different reason on projects and share parts of these projects back and forth. So we're going to have them present. So we got Tom Rogers from SW Rogers, Mike Trabucco from Shirley Construction, David Jurgen Doniger from WG Construction, and PJ Heflin is from CP&P, but he is going to be talking for Utilities Unlimited today on some of the water systems. I think we're going to have them present in order, but they'll probably go back and forth to each other because you'll see they're all interconnected as we go forward. And we're going to ask each of you, we'll start with you, Tom, just to kind of give your background so people get a sense where you're coming from. And I think they'll want this to be interactive, so ask a question at any point as we go.
On here. All right, can everybody hear me okay? All right. All right, as Ken said, my name's Tom Rogers. I'm Vice President of Field Operations for SW Rogers Company. And I thought I was going to be speaking to a panel of young, maybe college-age, up-and-coming engineers, but I see that's not the case here. So I have to check my facts. I'm just kidding. A little bit of insight into my career path. It's fairly straightforward. I've honestly never worked for a company other than SW Rogers. Never drawn a paycheck anywhere else. It is a family business. My father started it almost 40 years ago, and I decided at an early age that that's what I wanted to do. That's the path I wanted to pursue, and he agreed and said, all right, if you're going to do it, you're going to start from the ground up. So that's kind of the path I took. So I started pretty early in my early high school career, working in the summers as a laborer on various different crews, just trying to learn the ways of the sites, and soon started operating equipment, trying to become proficient there and getting comfortable with that. Eventually began managing some smaller tasks with smaller crews of my own, and maintained that path for several years. And by the time I graduated college, I was fortunate. I kind of knew where I was going, what I was going to be doing, and as soon as I graduated, I went right to work and managing sites. I became a site foreman and just part of the team, the SW Rogers team. And at that point, I guess it's kind of a natural progression in my line of work to eventually become a superintendent, ordering materials, managing subs, ordering stakeout, survey, blah, 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 all the stuff that a site superintendent does until eventually my title now, and I've held that for about a dozen years. So I guess in a condensed form, seems a bit like a fast track to where I am, but in reality, I started about 30 years ago. And so for the last 25 years, I've really spent a lot of time reading and studying plans, from erosion control to utility profiles to MOT plans to just about all parts of it. And in different levels, directing my company's resources, which are primarily our people and our equipment, to basically build what's on these drawings. And I've certainly made a lot of mistakes doing that throughout the years. But these days, I'm still primarily out in the field, but I do spend a lot of time with our estimating, our chief estimator and estimating department, going through new projects, trying to put proposals and schedules together, and still really studying these plans. And I find myself still a lot of times asking, well, why did they draw it like that? Or, I don't know if there's enough room for this to happen. I don't think it's going to work. Or maybe, well, the inspector doesn't allow that anymore. And finally, my all-time favorite, well, it's just not going to work. They got to go back to the drawing board. So when Becky and Ken approached us about this opportunity, I was all in until I figured out that I had to speak in front of a crowd, because I can tell you I'm way more comfortable in a 20-foot deep trench looking at an excavator than I am addressing a crowd like this, but I'm going to do my best. And I was a little bit intimidated, but I also felt like it's an opportunity for me to put a voice to all these comments I've been making. So over the years, to make it be known what I was thinking. So I eventually settled on a few topics that I wanted to address, and a third one if time allows. And I am hoping to turn this into a bit of a Q&A session, interactive, so I can get some understanding from your point as well. So if you guys don't mind kind of collectively tying half your brain behind your back to level the playing field with me, hopefully we'll all learn something from this. So topic number one. See if I can navigate through this PowerPoint. To me, it was pretty easy, something that I see a lot, and that is the challenge of installing utilities in narrow easements. And this is more so directed towards sanitary and storm than water main, because obviously they're, whoop, how's this? Need to go back a little bit. Stay. Can you get that to stay there for a second?
Oh, is it timing itself?
I think so. Right.
For those following along, this is
Nick.
the smaller packet that's on your table, the one that says SW Rogers.
Oh, sorry. It's still kind of clicking through. So I know a lot of you by name, and I've spoken with some of you by phone and never met you, but I guess I can see that a lot of you have site experience, some maybe don't. Does anybody here have actual hands-on field experience working on the ground for a site development company? No? This might just gotten a little bit easier for me then. I'm just kidding. That's fine. Does anybody know, well, you have the picture in front of you now. I wanted to give everybody an idea of how wide the footprint is of most of the excavators that and we all use about the same size in our industry, commonly use, and it is a 12-foot footprint. And that's regardless of whether it's a 100,000-pound machine, which is what we use to install utilities, or an 80,000-pound machine. But So pretty big toys that we're playing with out here. How about for all the engineers, the OSHA requirements for excavation and trenching? Does everybody on terms with what they require right now? Anybody? I'm sorry? They require a 4-foot walkway at the top of the ditch, yes. But if that's what you're referring to. But OSHA regulations for trenching and shoring, it's actually determined by the type of soil, and predominantly what we're used to and what we have up here in Virginia are Class C soils, and that translates to a 1.5 to 1 shore slope. So, by posing these questions, I'm just trying to set the actual stage for an actual installation. And you can see on the PowerPoint that I have an OSHA-approved excavation for an 8-foot deep trench. And what I find a lot is that when I get a set of site plans, they'll be issued with a dedicated easement of say 25 foot wide. And as you can see by the PowerPoint, that the width of the ditch alone exceeds the 25-foot easement. And that's highly problematic because 8 foot in our line of work is really not very deep at all. Not very deep at all. But it's OSHA mandated for a reason because it is a safety issue, and it comes down to basically it's a pretty easy formula. What OSHA is assigned to it, and it's 3 times the depth of your utility plus the bottom width of the ditch. So obviously, in an 8-foot deep excavation, the top of your ditch is going to be 28 foot wide. And if you go to the next one, I just added applied the same terminology to a 12-foot deep ditch, and you can see how much wider it goes, so wider it gets. So 25-foot easement really doesn't work when it comes to installing utilities. And there are a few other variables that go along with that. First, a lot of times you have to clear these easements. And when you have a 25-foot wide easement that has trees with 50-foot canopies, it's kind of hard to get them out of there without disturbing getting outside the flagging. In a lot of these ditches, you're not going to be pretty much anywhere in this area and get over 8 feet without the help of explosives. So everything needs to be shot. And that creates a mess in its own. But and the third thing, I think the third variable are the maintaining erosion controls. So I need to be able to clear this easement, put my silt fence up so Mr. Glass won't issue a violation, blast it and excavate it, and keep my erosion controls up at the same time. So by the time you clear for the easement, step in a few feet to install your erosion controls, your space is limited there again. So I guess where I'm trying to go with this thing is that if at all possible, check your depths, apply the formula, and grant enough room to safely install this, because one thing you cannot vary from are the slopes on these things, on these ditches, and it's a safety thing. So to me, that's huge, and that's something I'll never put my men in danger. That's for sure. So, well, is anybody familiar with the trench box situation? As you can see, I've applied the terminology from the trench box to the same easement, and it certainly does bring your footprint in, but by the time you have your spoils pile and material access on the other side, still 25-foot easement really just does not get you safely where you need to be. So if you can avoid it, please do. And what I was actually on site just the other day, and I took a picture of a utility trench, and this is about 12 foot deep. So you can see from the top of the ditch where the ladder is on the left side to the other side. It's kind of hard to put in perspective, but that is about 40 feet wide. And that's, again, just a 12-foot deep excavation, which really is not all that deep until you're standing there looking up at the excavator. But let me see. Yeah. It's a little bit more than that, but that's all right. It's done. It's okay. I just wanted to show the magnitude of the ditch and really what it looks like when you apply this formula to it. So, all right. Any questions? Questions? Yes, sir.
I always understood you could go up to 4 feet before you had to go into that 1.5 to 1 slope.
Yeah.
The exhibits here just seem to show that 4 foot
And
trench before you. Is that still applicable, or is that old, or is that?
in Class A soils where you have a trench situation, solid rock, you can. 4 foot is the maximum, but in Virginia, because of the type of soil we have and most everything shot, no vertical whatsoever in an OSHA ditch. That used to be what everybody went by around here, but for your reason, I think OSHA changed that. That's been 8-10 years ago now. So, all right. And the second topic is, let me see here if I can't get this thing to go for some. I'm struggling up here. Sorry, guys. Bear with me. I'm almost done. The second topic I had was the importance of plotting existing utilities, both overhead and underground, on site plans and the consequences of not doing so. And what I have here is just a site plan of it's actually a small project. It's a project that we're working on right now. And it is fairly simple site. As you can tell, it's a retirement community, and I'm zoning in on the access road that serves this property. And up in the top right is the actual building. It's a pretty good sized building and a parking lot. What makes it a little bit complex is that this, as you can see, the lighter shade blue is the proposed water line. I know I've got a lot of stuff going on here. But in between that blue water line and that yellow, which is represented by gas, there's an existing access road that serves an existing building back here, which again is not uncommon to work under traffic control. Happens a lot. It happens a lot. So we signed the contract, bonds are posted, sites flagged. I'm getting ready to start. 3 days before I start, I call in a missed utility ticket, go out there with clearing equipment shows up, and so does missed utility, and they mark in yellow a gas main servicing this existing building back here. And not only that, in the dark blue, a water service complete with a water meter, as you can see right there at the bend right here, and it continues out to this building. The existing building sits back here. The proposed building's back here. So none of this is on the plans. So we're getting ready to get started, and the idea is to start with the storm outfall and pave this street to give them access. But ultimately, what ends up happening is the job basically comes to a screeching halt, and we're basically in hurry up and wait mode because, as you can see, this gas main it's kind of a mess with the utilities anyways, but it parallels this entire storm outfall, and I did the best I could do drawing it, but it is only about a foot off the center of the pipe. So the entire gas had to be relocated before I got started. And we became a part of that. So we helped them work through that, but ultimately it was the same, I guess my point is it was the same misutility ticket call that I made or any contractor that works out here made. I feel like if it was made by the civil, we've been able to plot it on the plans, and it would have saved the owner a lot of time and a lot of money, because we basically had to hand dig along the existing water service. You know, there's a dedicated easement, as you know, for the water line, the proposed water line, which is just lighter blue. You need to stay within that, keep the existing service live as well. So it posed a lot of challenges. And as far as the gas goes, you can't touch that anyways. OSHA again precludes us from being able to dig within 2 foot of any utility with hydraulic equipment. So we basically, as we laid the water line, laid an extra conduit in the ditch for them to relocate the gas, but it was in and out, in and out, in and out. And there's a whole lot of, sometimes you can redesign something, sometimes you can make field adjustments. Sometimes you just need to start all over again. That's what happened in this case, and it really cost the guy a lot of time and money. And this is just you see it from time to time, but this is a job that we happen to be working on. So again, just a little bit of work beforehand, plotting it on the plans would have saved this guy a lot of heartache. So again, long story long, the call to Virginia 811 goes a long way. Yes, sir.
Wouldn't the owner have done a feasibility study on that before it even got to the plan being approved? I mean, he'd have to know what the cost was going to be to relocate that gas line. I mean, there's a lot of upfront stuff that's done beforehand before it come to use. I mean, it seems like the ball was dropped way before the engineers got it.
Well, I think he would rely on the engineers to show this being there. He would never have known that there was where the gas main was, even if he did know where the existing building was serviced by it. You need to know exactly where it is on the plans. So, I mean, in this situation, what I did, and it becomes a collaborative effort with the surveyors. I brought a hydro excavator out here and excavated in known locations. The surveyor came out and they plotted the lines as we test pitted them, so they can essentially build an as-built of that line. And he could plot on the plan. We knew where we were at that point. But yeah, I mean, you might know, even if he did know that it was serviced by this gas line, unless he knows where it is on the plans, it's kind of hard for him to design, or it's hard for anybody to design around it. But when they came out to mark the lines, I mean, the water meter's plain as day, right there, blue marks right to it, and from there on into the building. And again, we had to, this obviously got re-engineered and got moved out here out of the way, and by the time we figured it out, my structures were already made, so it's not as simple as just kind of moving it around. Sometimes the structures will work, sometimes they won't. In the case where it doesn't, he just bought a structure for nothing as well, yeah. But I think the owner's going to rely on the civil to plot these utilities out. And honestly, the civil can call so deep or anybody to go out there beforehand and help them figure out how deep they are as well. So, yeah, by the time I get it in my hands, I'm I'm only as good as the plans that we have, or any contractor is only as good as the plans. It would have surprised really any guy, anybody out there. So, questions? Anybody? Mike, I'm going to turn it over to Mike Trabucco with Shirley. Man, that was fumbling all over.
Background on myself, 14 years out of college now. Went Penn State, civil engineer by education. I grew up in the business side. My dad was a contractor, bridges, roads, infrastructure. So I grew up around it all my life. All I ever wanted to do was design bridges, structures. Quickly found out once I got to college that I really didn't want to sit behind a cue ball all the time, but I still wanted that fun and that field experience. So I transitioned back to the more building side, but kept my focus in structures and in the engineering world. Been with Shirley almost 14 years now. Worked there as a contract manager. So at this point, my role is really more of the bigger picture management, more than one job, keeping an eye on schedule, owner relations, designer relations, both on the design bid build world and the design build world. So we've got jobs where we'll work hand in hand with the designer to come up with the plan out the gate, and then we'll have jobs where plans are given to us, typically VDOT or Prince William, Loudoun counties, but jurisdictional basis, and we build from those. So, but that's a little bit about my background. This first section here, I'm going to talk about is coordination of the drawings. So we all understand that you guys each have your discipline. You got the water resources guy, you got the structures guy, you got the bridge guy, roadway person. Everybody's got their level of expertise. The MOT person's different. The signal person's different. But at the end of the day, all those drawings got to come together and it's got to work in the field. We got to build all of this stuff. And what we find more than anything is occasionally things get pretty cluttered. They get one piece over top of the next piece, but because they're on different drawing sets, one's over here, 25 sheets later, we didn't really know it overlapped. We forgot about how big things are. They all look good on paper. In CAD, that line's only but, a pencil line thick. But things in the field have thickness. They have size. So we got to remember how big those things are. So I got just a handful of plan sheets here. And I'm just going to highlight a few things that, not things that were wrong, but things that, as we find them in the field, maybe they could have been improved on, maybe they couldn't. You guys have design constraints. The owner's got direction that he's given you on what he wants or doesn't want, where he wants things, how he expects his site to look at the end of the day. So maybe there's nothing that any of us could have done to make it different, but if we know a little bit more going in, maybe we come up with a better package going out. So just a couple things on this sheet here. So you got a new 48-inch storm running right down the road. But look how close it is to the existing 18-inch that's there. You got a storm structure here. You got 48-inch there. You know this is deeper because it's outfalling. But we're going to be right up against this likely fairly shallow existing storm system with a deep trench like Tom just showed. How does that all get pieced together? There's no chance that the lines that are drawn on that page represent a 4-foot diameter piece of pipe, which in reality is closer to 5.5 foot on the outside. You quickly end up with 8-9 foot wide trench just to get your bedding. Takes up a lot of space. And then over here, they show this itty bitty little bump out. Back to Tom's point. How do you get a piece of equipment in there to get that end section in, get that outfall, or pick up that low spot that's out in there in the green area? You got to give us just a little bit of room to work at times. But it's understanding what we need so that you can give us that space. So here, an intersection. All the new features in darker black there, and the existing features, in the lighter gray underneath. But if you take a look, you got junction boxes over top of existing utilities. Over here. Maybe it has to be there, but in reality, it could be moved just a little bit one way or the other. it does in the field. You guys know that not everything you show on the plans ends up exactly where you thought it was going to be. Sometimes we have to move things, we move it around, it just works. Conduit next to a sanitary lid. There's a few of these, spots throughout here. And sanitary line there. You got this signal pole right here. Every set of plans, doesn't matter who designs them. Signal poles are just a circle in the ground. Depending on that mast arm, that circle could represent a 4-foot shaft that's 20, 25 foot deep. It's a contractor designed element, so it's not something you're responsible to design the foundation. But you got to understand what that foundation is going to be, how big it's going to be, how deep it's going to be. And some of the rock that we've got in the area, you're not drilling 20, 25 foot deep to put a foundation in cost effectively. So you're going to end up with a spread footer. Maybe they're 10, 15 foot square, pedestal on top. They're still 8 foot in the ground. But now you're hammering a big hole in the ground to get that one piece in there. And if we stick them too close or right up against sanitary structures or other facilities, water facilities, then we miss the mark because now that owner can't service his facility at the end of the day. He can't get in there and maintain it if something goes wrong. Or he's mad when we go out there to build it and he says, you're not building that on my easement. So we got to understand all those features and how they interact. So this is just another sheet, or a little bit different view of the first sheet I had. Well, look how many times the storm system crosses the road. There was a lot of opportunity to optimize. If we looked at it from a more holistic approach, sure, it probably made sense. I'm sure the designer had good intentions on why he or she put this thing together the way they did. But if you step back and looked at it afterwards and go, is there a better way? Could I upsize a couple pipes, but I take a bunch of footage out of the job? Sure. At the same time, this has got an active, smaller road that runs through the whole thing, so I'm actually crossing the road to put a lot of these runs in. And then I'm crossing a number of utilities that run down that existing road to put those facilities in. Less time we cross traffic, the less times we cross utilities, the more efficient our operations get, the better the product is at the end of the day, the less cut up it becomes, the better for everybody. And then something that we deal with a lot on the Shirley side, being more of the heavy civil horizontal world, phase construction. None of us like to sit in traffic, but we certainly don't like when they take a lane away from us for a long period of time when we go home. So that doesn't happen around here like it does in a lot of other states, a lot of other jurisdictions. So what happens? We're phasing the work so that we can keep moving people back and forth while we try to improve the situation that's out there. So you got to consider how we're going to maintain that traffic, how we're going to construct it, but the duration we're going to be out there. And then provide the necessary information so that when the contractor's bidding it, we can evaluate what's going on, how it's really going to be, what we should expect. So this here intersection, out Linton Hall, 29, anybody's familiar with Gainesville area, the massive improvement just off the top of the sheet. There at the railroad. Designer designed a detour to take traffic off the alignment. Improved the situation at the same time, gave some more lanes, worked pretty good. Designer missed it, we missed it too when we pulled it together. We built the detour exactly the way they showed us to it. Didn't catch it until we built this road all the way down to this intersection. There's a 4-foot vertical delta between the new road and where the old proposed road was. It's what they needed to have. You needed the new profile, but could we have done something a little bit different on the front end? Sure. Maybe we could have adjusted that detour alignment, caught a little bit of buildup as we came through in that phase, and that would have saved us from doing all 4 foot of buildup in the back phase later on. As a result, we also had substandard signal height for about 2 months. So if we would have done some things at the detour phase when we set the detour up, adjusting that profile up or moving some things around, maybe raising those signal arms or signal heads that fed the intersection, we wouldn't have had that 4-foot vertical jump at that time. It might have been 2, 3 foot. Something a little bit more palatable for the owner. At the same time, it's 4 foot of asphalt. There's a lot of asphalt and a lot of expense that owner chewed up in that intersection for no good reason, but he had to, just to maintain traffic moving. Some of the cooperation, we're expected to have at the end of the day. As a prime on most jobs, we take the lead, but at the same time, our owners never exclusively give us a work area. I've had one job where I had one contract, and I had another general contractor that was fortunate enough to get a job directly above me. He got the interchange, I had the widening underneath. We had to work together. Overlapping schedules, overlapping scopes. I'd have a sliver widening going up, they'd have a sliver widening coming back. It's unique, you don't see it too much, but if we don't have good collaboration from the design, the engineering, the owner side of things, and then the contractor is able to work together, all that blows up in everybody's face. So you guys got to understand what kind of collaboration you're going to have. Then you got the subs and the adjacent projects and other ancillary features that all play into how our sites work, how our jobs come together. Because at the end of the day, we can't impact everybody. And some of the risks, the contractor takes on to some extent. So existing utilities and conflicts. Yeah, in a lot of cases, we don't take on the full risk of, moving the utility. But when I find that conflict, my crew's down, I'm not working, I'm spending money, but I ain't getting anywhere at the end of the day. So, yeah, somebody has to pay the bill, but nobody really wants to pay that bill. That's not a change order I want to get. It's not a change order the owner wants to receive. So if we can avoid those conflicts by just doing a little bit more due diligence on the front end, we can work together on the back end a lot easier. Incomplete or inconsistent documents, plans. One sheet says one thing, and then you go to the typical section, you get something completely different. Double checking our stuff, it happens. We all make mistakes. It is what it is, but if we can try to be more cohesive in terms of our package, our plans, our information, make sure it says the same thing everywhere you want it. One thing to remember, sure, all of us, we're all professionals, but at the end of the day, we're not putting pipe in the ground. We're not the guy, putting that structure where it belongs. We're relying on the laborers, the carpenters, the foremen in the field. Some of these guys, lucky if they got a high school education. They're working their butts off to do the work that you guys all design. But we're relying on that lowest level individual to put it in the right place the way that you expected it to be there. So we got to give them enough information to work from. And then we can manage to make sure it ends up where you wanted it to be. The unforeseen conditions. Making sure there's enough borings out there so we can evaluate the rock situation. Additional rock, in most cases, that's on us. Site access constraints, how we're going to get in and out of the job. What limitations from a timing perspective that we're allowed to access. If there's haul restrictions or time of day restrictions, making sure we're aware of those. So, all important facets to make sure you're considering. If anybody's got any questions, I'll open it up now, and then I've got a few additional slides here on the back end that we'll talk about some more of these topics in a little bit different light. But all right, David, it's all yours.
I'm David Jürgen Doniger with WG Construction. We're a specialty subcontractor, about 100 people, and we work regionally here in Northern Virginia. Our primary work packages are cast-in-place concrete, box culverts, retaining walls, stormwater management structures, underground detention structures. But we set precast, and a lot of what I want to talk about today, and I want to make a couple points before I get into the slides, is my discussion points, permanent improvements, erosion control to permanent improvements are going to be material agnostic, meaning it doesn't matter. And you're going to see some of these examples, whether it's precast, whether it's ADS pipe, whether it's cast-in-place concrete. It's really about the thought process involved that we face as a specialty sub. You jump right in. And the goal here is really to discuss the coordination of erosion control phasing with permanent improvements whenever it's possible and practical. Before I jump into this, because it's going to sound like I'm complaining a little bit, I'm not. We are partners, in my opinion, throughout the industry. As a sub to SW Rogers to Shirley, there's a partnership. From the contracting side to the design side, it's a partnership. We're all in the same boat and we're all in it together. So anything that can be done to improve is really why I got excited about being able to participate with this panel tonight. And I really don't want you to feel that I'm complaining. In fact, there may be some fabulous reasons, as Mike was alluding to and Tom was alluding to, why this was the design that got put in our hands. But there are some things we can think about. Another thing that is specific expression I like to use is low cost, high value. And Tom mentioned in his presentation 811 call when you're doing some design work and field call. It's a 15-minute phone call. You'll be on hold for probably 5 of those minutes. Yep. And you can get the site marked. You can go out and visit, and maybe something that didn't show up on the feasibility study all of a sudden shows up in the field, and it's a game changer. Some of these things, the thought process is what I'm after, and like I said, it's low cost, high value. And at the end of the day, as Mike just said in his presentation, the plan might not change. There might be no difference from our discussion today to the plan that could have been, but just some things to think about. Okay, so discussion point 1. Watch out for large structures showing up in phase 1 erosion control. Yeah, I know when you go out and put a set of drawings together and the process, the engineering process of going from a landowner has a project, they have an idea of how many lots they want to sell in a residential, they have an idea of a road that they want to build in a public improvement, or perhaps a utility project. They have an idea of what they want to build, and they come to the design team and say, hey, this is what we want to build. Is this feasible? And you get a back of a napkin and start sketching some ideas. That evolves into a 10% plan. That evolves into a 30% plan. And there are some relics in those plans that carry all the way through. And maybe you have a fantastic plan that every contractor would love to build, and you go to the authority, I see Loudoun County, I saw some of the other counties, and sit in front of whoever the erosion control reviewer is, and he says, whoa, or she says, no, this isn't going to work. I get that. I'm not complaining. I understand there's a lot that goes into design work, and this applies to inspections. This applies also to plan review, and I see just from some of the name tags that we have all of those cross-sections represented. But watch out for these structures. It really doesn't matter from a material agnostic standpoint what we're dealing with here. So this is a large structure as part of phase 1 erosion control. This happens to be a box culvert, and in reality, this is a fairly large one, and it's over here on the left-hand side is where I want to draw your attention to. It's a triple cell. This was a 12 by 10, I believe. I could be wrong. I know that the span's correct. This could be pipe. This could be anything. It's a big structure. That's the point of this particular slide. Here it is showing up in phase 1 erosion control. And I'm sure if we went around the room, I could hear dozens of examples of why this shows up on this plan, and we have to deal with it. But here's the story behind this structure. This was a residential project. Developer wants to close lots. That's what it's all about. Closing lots, getting people in the houses. That's when the payday starts for all the investors. They try to minimize their costs, the developer, all the way right up until the last minute, right? And then all of a sudden, whoever the winning site work contractor is gets a phone call, or maybe it's a series of meetings of negotiation, whatever it is. Go. Developer says, give me the approved set of plans, because we don't have that one yet. That's something that happens to us a lot. We have the bid set, and then things change, and then we get the approved set. Okay, So now we're ready to go. We've got the approved set of plans, roll them out on the table. First thing we do, Tom, Mike, what do we flip to? Phase 1 erosion control. Second thing maybe Tom and Mike would do is flip to where the tie-ins are, but we're going to stick on erosion control right now. Oh my goodness. How are we going to do that? At this big structure, this one was over 200 feet long. Okay, regardless of material you have, I don't care, precast, cast in place, pipe, doesn't matter. You have to get this thing in the ground in order to get in Loudoun County to go from pink to green, green to pink, I don't know which direction it goes.
Pink to green.
Pink to green. But you're going to be tracking a tractor trailer full of materials. It could be rebar, it could be pipe that PJ put together, it could be concrete trucks coming in here. You're going to be tracking that in and out of the site. You don't really have your sign off on phase 1. You can't do anything else. You can't strip topsoil. You can't put pipe in the ground. You can't build a road. You can't get lots going. And what's happening on the developer's clock? Tick, 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 right? So we're wasting time towards payday. Not necessarily for us, the contractors, but for the developer. This may have come from the county. This may have come from the county reviewer. This may never have been on the plan to begin with, and all of a sudden everyone started looking at it being like, well, how are you going to get this box culvert in once you have all this street and overlots done and all this kind of stuff? We got to have this thing in phase 1 just so we don't have to think about it anymore. Maybe. Something on the back end too, which I know Mike and Tom also probably start shaking your heads. What happens at the end of the job? You've got this thing in from essentially day, let's say it took 60 days to build, 90 days, whatever, from when you get your design done. What happened at the end of the job? The whole site was denuded. Equipment, tracking, want to get off bond. They look inside that structure, and what do you see? Cracks. Big time sediment. Now, in this case, this was a big structure, but think about it. How are you going to clean that out? Not with any equipment that's going to produce any kind of diesel fumes. I mean, that's 200 feet long. So maybe an electric dozer, maybe by hand. You're not going to flush it like you would storm sewer. Something to think about. It happens. But like I said, I'm not complaining. There's probably a good reason why this is on the structure, on the plans to begin with. I'm just trying to give you guys some food for thought. Also, as site inspectors, a good question, you have a set of plans, if you know, in the spirit of partnership with the developing team and the developer, is maybe you go back to the office, the erosion control office, and say, hey, I've got this phase 1 erosion control plan, it's got this big structure on it. Like I said, it doesn't matter what it is. Do they really have to put that in before I give them the green? I'm going to trip over which one's which because I don't deal with it. But do I have to, before I sign off on phase 1? And maybe they'll say absolutely, and I'm not going to tell you why, or absolutely, and they'll give you the story of how that got on the plans to begin with. Any questions on this? Yes?
Yeah, so we end up doing this a fair amount of times, and usually the reason is to divert some sort of water course so that you can more easily develop the rest of the plan. And usually that's why, you know, a permanent structure would go in early. If that has to happen, do you have any suggestions as to what would make that better from a constructability standpoint? Because many times we do, you know, end up needing to do something like that.
Absolutely, and I'll open up to Tom, Mike, and PJ. PJ's, you haven't heard from him yet, but he's an expert in structures as well. And from my perspective, if you have the ability to make it an optional stream diversion, or install this, maybe in the erosion control narrative. Maybe you don't have that. The second thing, show the stream diversion. And then give the contractor the option whether they're going to build this or not. So a stream diversion with a stream crossing, I'm actually going to modify what I just said. So sometimes what we get is we'll see a stream diversion on phase 1 erosion control, but there's no stream crossing. There's no way to get over it so you can get back on the other side of the plant, on the other side of the job. And that becomes an issue in the field. Tom and Mike, I see nodding heads. If you've got anything else to add on the end of that.
Well, I do, and I almost went with this topic as well, because whether it's, say it's not of this magnitude, but say it's just a 60-inch class 4 RCP because it's in a permanent state. What I see a lot of is, that's fine with the erosion control showing this pipe going through here, but on the final site plan, your sanitary goes underneath it. And it's not very often shown in a phase 1 erosion plan, but you're never gonna build any kind of permanent structure. Turn around and take it back out and put your sanitary in, and then take it, and then, I mean, you're not gonna tunnel it. So the deeper utilities need to go in first, and if that needs to be taken into consideration when any permanent structures or pipe are included in the phase 1 erosion plan. And Greg's not going to want to see too much activity, too much disturbance in phase 1, but you're not going to put it in, take it back out, put sanitary in, put it in again. So looking ahead, what utilities are involved with putting those erosion controls in is, in my opinion, huge. See it a lot.
Good question there.
The one thing I would add to that too is you're designing this large structure for an ultimate condition, whether that's a 50, 100, or 200, whatever the storm is that you're designing this big structure for. Phase 1 E&S, you might be able to get away with a 2-year storm, a 5-year storm. So this big box culvert or multi-barrel system, maybe it's 1 barrel, gets me across, gets me through my site. I can now do what I need to. I don't risk damage, I don't risk silt to that permanent structure, and it gets you an option.
So from a contractor's perspective, that's preferable then? Because I think a lot of times designers think, well, shoot, we'll just use the final thing, we'll save them some money.
Right.
And if that's not the case, that would be awesome to know.
No, I'm fine with
That
using
theory.
2, 3, 4, 36-inch corrugated metal crossings.
Right.
I'd rather see the CFP in there.
Yeah.
You know, it really makes no, I can go either way. I just need to see the sanitary in if you're gonna show the permanent. That's where I am with it. To me, it really makes no difference. I'm always gonna try to do what's right for the owner and what helps him out the most. Sometimes you cannot avoid it. Sometimes you're subject to wetlands impacts, in which it's a time-sensitive issue. But my thing is, again, is I can put temporary pipe in. It's not a problem. You can beat it up, get the timber out. I mean, that kind of stuff takes a beating when you're still in the clearing process. So yeah, that's not as much an issue as it is just showing all the proposed utilities and how the phase 1 plan affects the ultimate plan.
Yeah, keep in mind, at the end of the day, most jobs, whether they're private or not, we have to TV a lot of these facilities now. That's pretty much the requirements across the board. So not only are we TVing for silt and the obvious, blockages of sorts, but now we're measuring cracks down to the millimeter, joints down, less than an inch. So these structures that we put in early have a much higher susceptibility to damage just from the 100,000-pound machine, the soft soils that are above them, maybe minimal cover. You needed a big structure, but you got 2 foot of cover over top of it to your finished pavement section.
Mm-hmm.
So need to consider all of those facets and see how we can minimize things. If it's something you can put in the plans as an option, as build the permanent, or here's a temporary if you got to use temporary, and then the contractor can make that decision.
PJ, I saw you jumping in, or was that?
No, I would say most of the time the contractor prefers to put pond piping in, RCP pipe in phase 1 if it matches the ultimate. Pond piping is not a huge lead time item. Box culvert, you're spending cast in place. You're spending a great deal of time out there, and the clock's ticking. So, but we can.
Or precast, you're spending it at the plant, right? So either way.
The ultimate condition, if from phase 1 to the ultimate, if we can get it buildable, a lot of times you might raise a riser up 6 inches, and and it's almost impossible to make an 84-inch, 6-inch riser. Just you try to make it buildable in phase one to where we can get it to an ultimate condition. And my contact information, you'll have it, but a phone call, I can help you with all the specifics on that.
Yeah, absolutely. I think that probably goes for all of us. In the spirit of partnership, I have civils call all the time. In fact, I talked to you before about, some of these issues as you're starting to go through them. And oftentimes they're a couple of years before the plans actually are ready to actually be built. I want to just jump on that one comment that Mike made. That's really important from a structure standpoint. That again, I'm trying to be material agnostic on this discussion, but that a structure is designed for a certain amount of dead load, a certain amount of live load. And if you're scratching this culvert in and you're putting back basically to existing grade because you haven't done any fills on the rest of the site, but this ultimate condition is a 20 fill, for example. You're running 100,000-pound excavators, 30-ton rock trucks over the top of the structure without having the right amount of dead load to displace the live load of the ultimate configuration. You're really putting the structure at risk. You don't have the same issues with pipe, but pipe has a bigger range.
You need to have a 3-foot over top of the pipe or during construction. I mean, it happens. A lot of cracking in concrete pipe happens from the rock trucks.
Yeah.
Dozers.
So
without the 3-foot condition.
Yeah, good question, and definitely worthwhile. If there's a way to put it as an option and let the contractors figure it out or take risk on bid day, then that's up to the contractors. It's up to gives the inspectors the leeway to say, oh, there's an option here. We don't have to hold up phase one. There's also quite a bit of work, and this is the last comment on this slide. It's going on a little more than I anticipated. But there's a lot of work to get this in. There's a lot of excavation, topsoil, haul road that needs to be brought back there. And, it could be pipe, same thing, track trailer pipe. And you've got track equipment hauling the pipe back there. The end walls would have to also be moved back there in some fashion as well. So in the spirit of phase one, where you're trying to minimize your footprint on the site, this really doesn't help with that. So this is an interesting structure, and I don't know if there was a better way. We found a better way in the field, but it was tough. This site was like this, and you can see it in the grades. So we're looking at this thing right here. And you can see these grades, 2-foot contours. Start counting those up to the top of dam elevation. I think you'll end up with around 20 feet. My memory is this structure was 24 because we had to put this base all the way down on existing grade, actually cut topsoil and go down a little bit deeper and build it back up. You can count the contours going back down. At the top of the structure, the grades ended up tying into the size of the structure. So there's a pretty big capacity in the pond. And this was catching water for the entire site. I didn't show the erosion control plan on this one. The temporary basin on this particular drawing is right here. Nearly impossible to build in the spirit of construction. So now you've got back to the point that Darren was making, let's put the permanent one in on day one. This structure was 24 feet tall, 14-foot diameter, round. And if you look at this little piece of pipe that comes off the side here, it was shown as RCP. It ended up being ductile. This happens also a lot on plans. For some reason, we see 12-inch RCP specified for these dewatering devices. Inside the structure, what you don't see is there's a sluice gate. So that's not sitting on a shelf in most cases. There's a lead time. So right off the bat, we've got to do a structural design to make this structure work. And it could be precast, it could be some composite material, it could be cast in place. Again, doesn't matter. It's a big structure. It could be really heavy, and you've got to get a big crane in there. You got to get a big tractor trailer in there with the base, stack it out. It could be poured in 1 cubic yard buckets. You could be building it by hand. If there was some kind of fiberglass thing that you could make work here, you could be sitting there hand setting it. Either way, it's a lot of activity to build this structure. But what's happening while you're building this structure per plan? This dude right here behind you is filling up. This site was tough. There, by no stretch of the imagination am I trying to allude that there was a significantly better mousetrap. But what did we do in the field? How did we build it? I can tell you invariably when you get a job like this with a challenging structure like that, it gets built December, January, February, March. Guaranteed. It doesn't matter. We get the plans on bid day. When do you think it's going to start? Oh, it's going to start in July. Yeah, that doesn't happen. We were fighting water the entire time. We put several forebays above us, our site contractor did, several forebays above us to be able to capture this volume with some check dams. We didn't even use the basin that was shown on the plans. And that, in the county that we were working in, was challenging. That went all the way back to the reviewer to redesign the erosion control plan, but it got all the way through plan review and issued a construction set of drawings with this enormous thing on here. The other thing that was challenging is we had to run all this fill in this dam, which was incredibly large, with this pipe coming up so we could ultimately cast it into this structure over here. This was a monumental undertaking to make this happen. And meanwhile, I go back to where's all the money coming from? The developer wants to close on lots. We didn't start our first, oh, we did. Sorry. I don't know if it's shown on here. Sanitary sewer. There it is. Sanitary sewer tied in way down here. So when we went to the county with our customer to change this plan, we're downstream. We said, we've got to make this tie-in before we build this dam embankment. There's no other way to do it. And that wasn't shown on phase 1 erosion controls either. So this is a situation, you get a really challenging project like this. It all looks good in its ultimate condition, but call contractors then. Get some of their thoughts. Low cost, high value, you know. Half-hour conversation over the phone, you know, could save a whole lot of headache. That job stalled as we worked out these issues because the site contractor realized there's no way that sanitary could be installed if the permanent pond was in place. All right, don't want to be a dead horse. Anybody have any questions? Discussion point 2, watch out location of sediment basins and traps in phase 1 erosion control. And we've been talking about that, and I think these next couple slides will go pretty quickly. Here's one where I put side by side phase 1 erosion control and the permanent structure. Pretty benign, but if you actually get into what it would take to build this thing, this is a really tiny rear wall. It's really not that big of a deal from my perspective. But you've got your permanent pipe right here. Your temporary pipe. I know I said something wrong. I wasn't sure what it was. Your temporary pipe right there. It's challenging phasing when you're going to switch. Now in this case, we had a phase 1 erosion control plan that showed temporary pipe, but it's that transition. When can you transition from phase 1 to phase 2? This project, why was this difficult? And this is going, I think, back to Darren's point. After the houses were built. So people were living in these houses, and we're trying to get back there to put in this weir wall. Not a big deal, but there are kids playing, there are people who don't want their yards that are all nice and sodded, torn up. But we couldn't actually, because of the way the construction was so aggressive to get those houses closed and sold, this was a big deal. And now we've got a pond that is holding water. It's been holding water throughout construction that needs to be dealt with in order just to get that little tiny baby weir wall in there. This would be a great circumstance where the phase 1 gives you that option, or there's maybe a phase 1A where you could build you can transition from temporary to permanent. Any questions on that? What do I have here? This one's challenging phasing. So this was a monstrous retaining wall there's no better way to do it, to be honest with you. There's no better way to do it. But just look at it. Here's your pipe. Here's your basin. You look over my left shoulder, this is the permanent pond over here. We're outfalling through the weir wall of the permanent structure. There's no better way to do it. There's a tremendous grade change. These ponds, I don't remember how many acres this was, 3 or 4 acre pond, holds a massive amount of water. Just tough. That's the only reason I put it on there. It's a challenge. I couldn't tell you and I couldn't proclaim to be able to give you a better way to do it. But the whole time that you're building that weir wall, you're coffer dammed off, trying to hold back the water, pumping water, trying to get the riprap in, ultimately closing up the hole. Difficult. But I couldn't tell you a better way to do it. Better phasing. So this one's better because it could be done. And here, really quickly, temporary pipe on the right side, coming out here, tying into the ultimate spillway, and then tucked in the corner over here is a structure. Fantastic. When this pond was built, ultimately what we ended up doing, it wasn't my company, but the company we're working for, built the coffer dam here and just isolated that area. So we could come in after this was done, when the timing was right, build this structure, run this little piece of pipe, and when you could transition from phase 1 to phase 2, yank the coffer dam, desilt the pond, put in that little grading piece, and everybody's happy. So that's ideal, but you don't always have this kind of real estate to deal with, I get that. But this is a much better in the field transition. Any questions on those 2 items? All right, so this is just a quick summary, really restating the other 2 slides. So if you're reading it and you have deja vu, it's because it's exactly the same words that were on the other 2 slides. And that's the end of my piece. So I'm honored to be able to participate in this panel. And if you guys have any questions about anything we discussed, happy to address those now. Okay, thank you guys. Oh, did I miss one?
I would say that probably, in addition to the large structures, is because it has a large drainage area. So,
Absolutely.
as Tom was saying earlier, that's going to have ramifications with permitting, wetland permitting, whether you can capture the sediment upstream of the structure, and it is a difficult endeavor. And as Darren was saying, oftentimes you don't have an option other than making sure that if there are other utilities, that they're also included in that baseline.
Yep. Yeah.
Because your hands are sort of tied. A lot of fill, large structures, large drainage area.
Absolutely. Yeah, and I think that's a great point that actually ties back to what Mike said about having the different project engineers collaborate at some point. You know, if you've got a line work guy who's working on the line work, you have someone who's doing erosion control. And I don't know how your firms are structured individually, but if there's some, we also build water, wastewater sewage pump stations, so we call it systems integration. I don't know of another way to say it, but to actually integrate all those plans so they're coordinated. And Mike's actually going to talk about some of that in some more follow-up slides. You know, there are some quick changes of a mouse, clicks of a mouse, and it can really change the whole, you know, dynamic of the project. So, and like I fully admit, sometimes that's the answer. You know, what we get, and you know, we complain about it, or it's difficult to build, but that's why you hire professionals to do it. We have to overcome those challenges.
I gotta say, it's very rare that I'll install a sediment basin exactly to plan. We're always conscientious about meeting the capacity, but I might, if it shows that it is definitely going to be a temporary pipe and structure outfall, I always relocate it or move it far enough away that I can ultimately, whether it's a structure, cast in place structure, or precast, that I could do that and still have the temporary pipe functioning far enough away where I can safely put it in, because you need it to function as well, and you need to be able to structurally put the permanent stuff in as well. So If it's not, I don't always, I'll have a discussion with the inspector. As long as I meet capacity and the grades are, it's functioning, we vary from it a lot to be able to make that transition easier. Happens a lot.
Thank you all. PJ's up next.
Want to take a bio break?
Let's take a 10-minute break before PJ starts. A lot of people in the room, let you get out and get back in.
Hi, Amin. How are you doing? I don't know if I've ever met you in person, but yes.
Yes, email. So
Yeah, exactly,
that was
yes.
Vincent, huh?
Yes, yep.
Aaron Vincent.
Yep.
Yeah.
For the
Nice
lot
to meet
6B.
you.
Nice to meet you as well. Yeah.
I was really, that same topic, I want to see that a lot. What's that? Box culvert. All of the diversion is into the wing wall, and you gotta backfill the whole thing, and then come back later on.
He remembers.
Dig out for the wing wall. Enough room. So,
Make it home before dinner.
All the way hard time.
6.5, 4, 16. How about you?
2 10-year-olds,
Twins, man.
twins, a boy and a girl. My wife has her hands full most of the time. So, it's good.
Yeah.
Bristol. I'm right between Bent Hill and Flint Hall on Southern. So yeah.
But I'm Ed Wagon, I'm with
How you
Viking.
doing? Yes, sir. Good to see you.
Really appreciate,
This PJ had for us here.
Discounts for us.
Sure.
How long have we been okay, PJ?
Is this a discount zone?
Discount sheet, right?
Oh, yeah, I got it.
With that
Wait a
much
minute,
time.
I pay way more than this. I pay way more than this. This is through the Hazel.
Neither one of you did.
Hey, the first time I looked at this, or when I first looked, I'm like, wait a minute, so it got cheaper. What's he
We
ship?
changed the E inlets.
Well, yeah, and then I
changed
start looking at the bottom, and I'm like, oh, okay.
It'll be an interesting
Changed
transition.
pipe to HDPE, and this is what happens to the structures. You can put boots.
Oh, they made it go to boots.
No way. I can't stand that HDP.
That's,
I don't like it
it's
either.
a good example. I just
It's
added.
good. Because I'm telling you.
Right, exactly.
They're not telling the whole story.
I don't like it. I'll buy those storm packs from them all day long.
I'm sure you'll never actually get off.
Yeah. Oh, yeah.
Yeah, VDOT makes you backfill all the way a foot above the pipe and get compaction around the corrugation. So when you get compaction on 25 around corrugated plastic pipe, it gives on you all day long.
They say it's cheaper, but it's so labor intensive to backfill. Either use clean stone.
And VDOT won't
All right.
let you clean.
Right.
The only place you can
Scott, we'll go ahead and get started.
Like that where you can't use clean.
My name's PJ Heflin. I'm with Concrete Pipe and Precast. I've just celebrated my 20th anniversary with Americast / Concrete Pipe and Precast, but I've been in the business since I got out of Virginia Tech in '91. I worked for Ferguson doing water and sewer for 3 years, and then I've been in the concrete business for about too long, probably. So I worked for a company called Hydro Conduit, which is now Rinker, but 20 years with Americast Concrete Pipe and Precast. All that being said, we're about a 650 person company with 13 plants stretched along the Mid-Atlantic from Charleston, South Carolina to Greencastle, Pennsylvania. We manufacture precast manholes, inlets, we do box culverts, we do pipe, specialty products, we do dry utilities, Pretty much anything that we can make out of concrete and put on a truck that we can keep under 30 tons and less than 14 feet wide, we can build it. We build it out of panels. Our pipe is more automated. Precast is more labor intensive and requires a lot more hands-on than pipe does. Our goal as a company is when a contractor hands us a set of plans to build is for them to sort of experience a sense of relief than anxiety when they hand us a $500,000 precast job. That's our goal. Sometimes we make mistakes, but we like to think we're the best at what we do. And our clientele, we try to associate ourselves with people like Rogers and Shirley, the cream of the crop when it comes to contractors installing our product. I just want to, this is a late ad because it just happened. This is a copy of a quote that William B. Hopke's a great customer of ours. The job changed. The job changed, and I'm not here to bash alternative products to concrete, but it changed from concrete pipe to HDPE pipe. And the price, so the handwritten numbers are when it was concrete pipe. It was $29,000 quote for our products. It changed to HDPE pipe and required boots, and it went up to $43,316. So an increase of almost 48%. Well, so that happens quite a bit, and some of it we can't control. Like I always want to see concrete go on the ground, but it happens. But when you guys do that, I'm sure the owner's driving it. What percent of the time? 100? So, but you're not getting the whole story as far as cost, because it's not only the increase the price in the structures, which is it's significant compared to a bid date about this time last year. It's the aggregate that goes with the HDPE pipe, and whatever your bucket, whatever your trench width is, you have to go a foot above the pipe with your stone on HDPE pipe. It's a lot more labor intensive to put in the ground. Now it might be cheaper as far as the linear foot price, but there's a lot of variables that come into play, and it's not just the linear foot price of the pipe that should drive the decision. So I just wanted to let you guys know that there's a lot of information that you're probably not hearing from the HDPE guy when you put it on the plans and switch it out for concrete. But this is just something I think you guys would easily agree with me that there's a lot more variables. Yeah.
So what makes the structures more expensive?
All right, so if you look at this, we manufacture diameters 48, 60, 72s. The ones that used to be 48s are right here. They're listed as 48. They had to go to 60 because your 24-inch HDPE, the boot requires a hole that could only, a 60-inch diameter structure will only take that boot because you don't have enough wall on the circumference. Your boot has to jack into a cord opening.
To PJ's point, you're much better served if your owner wants to change like this from one type to another. Give the contractor the option. At the end of the day, all the owner's looking for is the cheapest product he can put in the ground. If you give allowable pipe types, VDOT does something very similar to that, where if they got a table, you pick what you want. Let the contractor pick, and then he's going to give you the best price on bid day of whatever he can put in the ground. And then everybody wins.
So it seemed just by looking at this, using concrete structures and HDPE pipe might be the least expensive approach?
concrete structures with HDPE? Not necessarily, because you have the stone backfill and bedding. With concrete pipe, you maybe have to come up to the spring line of the pipe.
Yeah, so the material pricing, concrete versus HDPE is definitely cheaper HDPE, but it is much more stone that you use per foot.
One HDPE.
On HDPE, yes, and it's way more labor intensive because of the backfill.
Is that gravel just for bedding or all around the?
All around for HDPE.
A foot above.
HDPE is a foot above the pipe
Is that the reason why?
to get your structural
Yeah.
equivalent.
Because you're creating, with plastic pipe, you're creating the strength, the pipe crew's creating the strength of the pipe. With concrete, 80% of the strength of the pipe comes from the pipe crew.
Yep.
With concrete pipe, 80% of the strength of the pipe comes on the truck. So
I know another factor might be, well, what I've seen is that the end value of the pipe needed to be reduced because they were hydraulically challenged by something. They had to get the water out, so they went from concrete to HDPE so that they could get that water out faster.
yeah, I've seen it actually on one of your jobs, Lifetime Fitness. They used an end value of 12 instead of 13. So understand all those circumstances.
Will there be some savings in mobilization of the HDPE versus the concrete? I mean, because I think the pricing probably doesn't consider mobilization of the materials to the site, or is that like very little?
Easier to handle.
Mm-hmm.
Yeah, I'll let Tom address
Yeah,
it.
I mean, the price per foot, that's included in my price per foot that I buy it for. And it's definitely easier to get 500 feet of pipe delivered of plastic than concrete, yes. But again, all things considered, to go along with the slide I showed earlier, if you were able to dig a perfectly 6-foot tall vertical ditch and 36-inch pipe, foot of stone on either side, a foot above it, you could probably salvage a lot of stone, but the way we have to lay it back, you use so much more stone than, and I have to price it that way. So the stone material price per foot is considerably higher per linear foot in HDPE than it is for
And
concrete.
the compaction of it has to take place on both sides simultaneous.
Well, it's approved for both aggregate 21A type or 57s. 57s, again, is clean stone is more expensive, self-compacting. But if you go the other route to buy cheaper stone material for bedding, it's way more labor intensive per foot at that point because you're compacting in lists, 2 jumping jacks on either side, and it's slow and it's tedious work.
And for those of you guys that are doing DOT type jobs, VDOT's not allowing clean stone, the 57s around HDPE pipe. It's
21.
dense compacted stone, 21A, 25, 26s, and it's compacted. Keep in mind, all that corrugated HDPE has all the waves down the side. All that's doing the whole time you're trying to beat that stone to compaction is fighting your compaction because the pipe gives a little bit every time you beat on it. So the effort that it takes to get that compaction and then make the nuke gauge guy happy takes a much longer time.
But to answer your initial question, to buy the material itself when you're comparing HDPE to concrete,
Yeah.
it's definitely cheaper for me to buy that pipe, and it's easier to get it delivered. To answer your question, but there are many variables to consider with the installation.
I got something to add. I remember sitting in a lot of these plastic pipe, I don't know, symposiums or, the maker would come over and give us, brown bags and tell us about their product and whatever. And they're always touting about how much easier it was to transport this plastic pipe. You could have laborers out there moving this pipe instead of your machine out there running around on the site. Is that not the case? I mean, are you guys, do you
No
have
doubt.
your laborers running around with this 36-inch pipe? putting this
No.
on the ground?
Oh, I'm sorry.
No, I mean, it's hard to lift a piece of 24. probably 3 guys lift a piece of 24-inch, but maybe 12 or 15s. But that stuff is, I mean, I don't want to bash it, but because we're not here to do that, but well, all things being equal, it's pretty even, and at the end of the day, you've got, with concrete, I mean, it's proven life.
Well, I'll answer your question in this form. I'm going to have the same equipment on the pipe crew, whether I'm using plastic or concrete pipe. And my loader's gonna have a set of forks, and he's gonna go over there and he's gonna pick the pipe up and bring it over to the ditch. And yes, it's definitely easier to handle. The 24 is obviously lighter, but it's still gonna have a sling around it, and it's gonna be lowered into the ditch with the same excavator.
Good to know.
So, I mean, you know, it still goes in the same way, and I'm not gonna say, well, I'm not gonna supply my pipe crew with a loader because it's plastic pipe, because it's, you know, you still need to fetch stone and backfill with it. So it's still the same crew.
We did.
It's definitely easier to handle for sure in the ditch.
There's pros and cons, but we did a test at the concrete pipe school in Phoenix. I was witness to it where they installed 24 feet of concrete pipe, 3 8-foot sticks, and then 20 feet of 24-inch HDPE, and then they had 2 pipe crews bed it, backfill, and they bedded and backfilled the concrete pipe in like 24 minutes, and then it took them like 48 minutes to get the lifts and get a foot above the 24-inch HDPE. So.
How do you get like in the middle where you're compacting on either side, how do you keep your pipe from like bowing? You know, like being pushed up out of where you're trying to compact it into? Do you hold it down with something, or?
The plastic pipe,
Yeah.
it's heavy enough to where it'll withstand a jumping jack on the side of it.
Okay.
But you have to, the first lift, it has to be at least it has to be above the spring line to be able to, because you're right, it will have a tendency to float
So then
as
you'll
you're,
have this, like bow
yeah.
and pull it run. It's
right.
like-
And you're talking 20-foot lengths versus 8-foot lengths. And on really flat grade, you know, 0.5% pipe, it's critical.
I think, you know, one of the things with HDP pipe versus concrete is you see it up here, but you don't see it like you see it in areas where it's not inspected, which is like the valley or where there's, you know, you don't have enough inspectors to, there's no video in pipe unless you're around the suburbs of DC. So once you start videoing it, then people want to tend to lean towards concrete.
There's a time and a place for all pipe types. You know, there's the one job that I had the slide there with the intersection, grade separated. We've got both pipe types on the job. I got pipe inside of the MSE walls. All of that's HDPE because the stone's not a factor. It's all clean stone anyways, and I'm trying to finagle pipe between straps and other features as I braid this stuff through the walls. So really not laying it with pipe crew, I'm not digging a ditch. It's not traditional pipe. But every piece of pipe on that job that's laid in any sort of earthen condition, it's all concrete. So you got to know, and that's where, like I said earlier, if you give the contractor the ability to make the decision, he's going to give you the best price he can with the right product that he's comfortable with. You know, one guy that owns one set of fleet of equipment, like Tom's point, he's going to bring that same fleet of equipment no matter what he puts in the ground. But you might get some different bidders to a package, a small site, whatever, if he's got the option to use some smaller equipment that he already owns.
And I think also it is a regional thing, because if you're able to use the native material to backfill this pipe with, which in certain sandier gravel material does meet their backfill specifications, well, in that case, close your ears, PJ, it's a home run, right? Because I don't need to buy that stone. But I guess my contention is, I don't know, I'm gonna say 75% of the storm that I install is shot. That means, obviously, it's rock, and it's not conducive to anything but manufactured stone is bedding. So we don't have that luxury up here, because so there's so much blasting. That's why the manufactured stone cost for backfill is introduced into the equation here. Whereas if you're in, I don't know, tidewater area where sand and
Eastern Shore, Maryland.
yeah.
But anyway, thanks. That I just added that in. Didn't have a slide, but you get the picture. You all ever have? You're sitting around wondering, hey, can I fit these two pipes in a smaller structure, or if I spread these pipes, more than 60 degrees, will it go in a certain size structure? I've got all of our angle charts on this flash drive, and I'll give it to Becky, and she can publish it to you guys. So it's our diameters of structures, 48, 60, 72, 84, 96, and 120s. And it tells you what pipes are the most acute angle of two pipes. So you'll just follow the chart. I got a 54 and a 48 at 75 degrees. The one on the plan is 85, so I can put that in a 120, something like that. So she'll publish that to you guys. So I gave you a handout on this slide because the slide stunk. What this is Founders Row. It's a job we're doing right now, and they're taking a 42-inch pipe, and they're going to pull that out of the ground, and they're going to run a 4x4 box culvert. You can see it on here over to a junction box, and there's an existing structure right here that takes that 42. I think this is a 42. The existing structure gets pulled out, and the engineer said we're going to build a junction box on the end. We're going to build a junction box to take the 4x4 box and come over here and catch this 15-inch pipe right here. So the box ended up being, it was big junction box, probably about $12,000, $13,000 precast box. Now, I don't like to usually walk away from a $12,000 or $13,000 precast box, but I said, well, you could make a 6x6 junction box and put a 48-inch pipe or a 48-inch manhole here and stub a piece of 15-inch down. So it ended up being about $6,000 instead of $12,000 or $13,000. So you have one more structure, but a lot of times you can change an acute angle, a pretty drastically acute angle, with a 48-inch manhole, and I suggest doing it because when you get up to the 60, 72s, and 84s, there's a lot of concrete, it's costly, and it would save the owner's money. So that's what the engineer took my idea and ran with it, and everybody was happy. Here's one. Here's a design. I think this is a data center. This is a blow-down meter vault. So this vault is measuring the sewer coming out of the building. And here's your regular sanitary line coming out. Well, they tried to bring it in at into a 40. That manhole you couldn't put it in there. So we talked to the engineer. The minimum you could put two 8-inch sewer lines in a 48-inch manhole is 40 degrees. 40 degrees of deflection. So they redesigned it, put a clean out, brought the blow-down vault straight into the manhole, and everybody was happy, but it took a while, and it brought things to a halt. If I would just say, anytime you can avoid an acute angle like that, and by adding another structure, because when we get acute angles, we have to go way up in diameter. And just keep that in mind. And the angle chart that we'll have Becky send you guys will show you how acute you can go in certain diameters. This is a water line. I don't know if you have a close-up of this. Okay, yeah. And I don't know what this utility is. This is a water line. Supposed changing elevation. And I think it's a 7. What's the station number? I think he had 7 feet horizontally to up like 12 or 13 feet. And they show it with 45s. But it just can't be built this way. I think what Mark and Daryl, they're with Utilities Unlimited, they told me they had to come up 45 and 11 and a quarter, and come up 45 and 11, or come down 45 and 11 and a quarter to get this water line to how they wanted it to be built. So I think the main thing is what they wanted to portray was it's not like how you draw it on the plans. And a lot of time it's how you can get it done. And we've been talking about that all day. So and what one estimator sees, another one doesn't. Wanted to talk about hatches. You know, we're seeing detention systems. We see storm techs on almost every plan I see. Detention systems, concrete detention systems, corrugated metal detention systems, and they all have to have access. So I think this is super important to me, because I think it's a safety concern, but it also becomes a problem, 5-10 years down the road. So I gave you guys a handout on this, but this is a detention system in the roadway at Chantilly Nursing Home that you guys did. And if you look in the handout, let me go back. Well, in the handout, I don't have it up here. I've circled the 3 Bilko hatches. Put a little circle around the 3 Bilko hatches called out for on the detention system. The smaller accesses are 30-inch cast iron frame and cover. Well, these hatches are, there's one there, and one down here, and they're all in the main drag here at the nursing home. So we're talking about fast trucks, ambulances. So I don't know how long we had it built. It could have been like not even a year. Every hatch failed. And it wasn't that the door failed, it was the hinges and the mechanisms to raise and lift the hatch doors. But they were all sticking straight up. The locks broke and boom. One of them was in a parking space. But my main point that I want to make is when a plow hits a round frame and cover, the plow gives. The frame and cover's cast iron. they're unforgiving. You can specify cast iron hatches for these detention systems. We don't even put them in anymore. We don't put Bilco, not bad mouthing Bilco because there's a place for it, but we will put in maybe steel hatches from U.S. Foundry or East Jordan. There's much more substantial hatches that you can put on these detention systems. Don't let, I guess the aluminum is Halliday, Bilco, Syracuse, but U.S. Foundry, East Jordan, there's plenty of people that make cast iron or steel hatches that are going to be unforgiving to plows. And so I was just out at this job. This is I don't know if it's a Bilco or Halliday, whatever, but this got hit by a plow the other day. And it wasn't that the hatch had buckled. It had been hit, it had been run over. It's near a dumpster pad behind a CVS in Warrenton. All right, so what's this cost? What's this cost the owner of the shopping center? Well, this hatch is embedded in a 4 foot by 4 foot by 4 foot riser sitting on a concrete detention system. Just because I'm not going to put aluminum back there, just the hatch, and they have to go in and cut the concrete because it's embedded in the riser. It's like $9,000 to get it fixed. It's probably going to be 25. Would you say
Yeah, I mean, your whole crew day, at least.
But if they just spent, so aluminum hatch price might be $2,000 and a steel hatch might be $4,000. So you got to spend it up front to get the longevity of it. When a plow hits a steel hatch, it's not going anywhere. And when a dump truck runs over a steel hatch, it's not going to buckle. What fails is the hinges and the locks. It's not the aluminum door. So that's a huge deal right now, huge. And Bilco will tell you they're traffic rated, but maybe in the corner of a parking lot is fine. That's still a wheel's going to sit on it. To me, if it's in the road, if it's in the easement, great. Aluminum all day long, but if it's in the street, if it's taking any kind of load on traffic, we really need to think about steel. Go ahead.
Could you speak to the constructability of retrofitting this to a round manhole at a 48 that's up and big, or constructing the same new on a detention system?
Well, we do put 48 risers on the detention systems when they have the 30-inch frame of covers, but when you have you could have put it in a 60-inch round flat top and had 60-inch access. We didn't do this one. This was one of our competitors. It would be much better if it had been a 60-inch flat top. You could pull the flat top off and you know, cast the hatch in a flat top and drop it right on there. Yep. So you might save yourself some money in the long run by making it a component item rather than something where they can't dig down. And even though this riser is sitting on top of the detention system, it's like 4 or 5 feet down. But we see it in the detention systems all over, and it's super important that we think about safety and long-term viability of the structure. Okay, here's DI-7s. Everybody's familiar with the DI-7s, I'm sure, in a paved area. Now, this is right in the traffic way. There's 3 of them. There's one in the easement. I would suggest we will not put these in a paved area, and we haven't done it for like 10 years. Because the DI-7, it's not the grate that's going to fail. It's the concrete that's gonna fail. It's a square structure sitting on a round 48-inch diameter manhole. And the cars will point load the top. It just, maybe if it moves a centimeter, it's rocking, starts rocking. And the concrete starts to crack. And the next thing you know, you gotta replace. And what do they want to put back on there? A DI7. The owner says, just put on there what they had on there. I'm like, come on. But we have a grate that's 38 by 38. It's by Capital Foundry. And it takes the same hydraulics as a DI7. Because a DI1 is smaller. DI1 is 2.5 by 2.5. And a DI7 is like 3 by 3. So my suggestion is a Capital Foundry CB 3838, and I will send the cut sheet on that to you guys also.
That's what you're calling it, CB38?
Yeah, and it's private, so most times you guys go right with it.
You don't have any problems with the DI1s, do you?
No, I mean, if hydraulically, a DI1 is much better. Hydraulically, if you can get the same flow.
In most cases, you probably can.
Yeah, and if you're concerned about a DI1 in a parking lot, we can set the DI1 grate up like 2 inches, so the pavement will come right to it rather than just exposing the concrete. So a DI1, but I will send the cut sheet on the CB38. The CB38 sits on a round 48-inch flat top. It doesn't rock. It doesn't move. I'll get that to Becky for you guys. But in a private condition, perfect. Yeah, here's the DI1 versus the DI7, our drawing. So you can see this part overhangs, and there's nothing underneath of it, unless you poured a collar around that. The thing about it is there's a cut sheet in the road bridge for a DI7 load bearing, and it's meant for median in between highways. It's not meant for parking lots, even though it says load bearing. Daryl and Mark wanted to talk about plan revisions. So I've been in this business a very long time, and it's amazing how it wasn't stagnant, but it's amazing how it's changed in the last 10 years with electronic Dropbox, with plans on the cloud. And we find ourselves building structures for Mike and Tom, and we've got them built, and they're sitting in the yard, and a new set of plans is just sent. Hit Dropbox, here comes a set of plans, and the thing's changed, and we're sitting on $10,000 worth of concrete that we have to crush, which the owner has to pay for. And the reason I say that our business has changed is because it used to be expensive to print a set of plans, and there weren't that many changes. The construction set was what you were going to build. Now we find that we see plans. We'll see a plan. This will drive you nuts, but we look at a set of plans, we're building off of it, then we get the revision that's dated before I got this set. And we could have saved $15,000 in scrap bases that we've already cored, customized for the job. So the one thing about revisions is if we can, this is a Phillips plan. It talks about the revisions. it deltas them here. It clouds them on the plan. I mean, this is a perfect world for us. But I would say if you can give us a hint as to what's changed, because a lot of times we're looking at a 200 structure job and we get just a plan and here it is, and we're like, what's changed? And you got to go through the whole thing. If you could give us a hint, give us a cloud. I don't know if that's standard operating procedure. We're just not, it's not trickling down. But if take a phone call from the precaster and he asks, hey, can you give me a hint for what's changed, or maybe an RFI from the contractor, it would save us. We find that our business has changed so much that we are, go ahead.
No, go ahead and finish.
Well, our business has changed so much that we are having trouble hiring enough techs to look at all the plans and how many times the plans are changing compared to 10 years ago. And it's because it's just in time. I mean, the plans are so easy to get to us.
So one of the issues we run into is you might be getting an early version of the plans prior to the official bid set or after, or way before the approval set. So normally most engineers mark revisions after plan approval. If not, I mean, sometimes you see first submission comments in black, second submission comments, a plan approval.
Right.
And then you start marking them in red after plan approval. So I think.
So we're building, the owner says, get started, I don't care.
And you might get the plans early, and there may be 3 black line revisions prior to approval and 4 revisions post-approval.
Right.
So it does become pretty onerous.
We just had a job where we did a full-blown submittal, structure-specific submittal, got it back on a Friday, approved, started building structures, and they sent us a plan like that 2 weeks later that was dated before the structure, the approved submittal, and they expect us to catch that. I was like, I didn't know what to do there. But that brings up a point of structure-specific submittals. If you guys cannot require structure-specific submittals on standard structures, that would save us a lot of time. I had no problem doing it on custom structures, pond structures, any variance from VDOT standards, great. But if we have to do a whole package of 120 submittals, structure specific, that I just can't hire enough engineering techs. I'd have as many engineering techs as I do laborers in the plant. So that's a lot of times how our business has changed also, not just with plans, but the fact that we can email you submittals makes it easier. It's easier to request things, and that becomes a huge issue with us.
I was going to mention, I'm hoping that you do see something like that, because just about every jurisdiction in this area would require a plan revision, and it's marked up pretty similar to that in just about every jurisdiction. So after plan approval, if there's a revision out in the field, it would be required to be submitted back through the jurisdiction, and it would have to be notated like that for each revision that you've done. So
We don't see,
hopefully you've seen something like that come through your shop at least one or.
when we're building it, quite often we're building it way before that. We get a lot of times like, hey, here's a plan, all your stuff's sitting on the job site, can you figure out the pieces and parts to make it work? And then so then there's an engineering tech doing that. And we're like, all right, you got to take off a cone and put a flat top, and it's like a big puzzle. but we do it, but then there's always pieces that are wasted, custom pieces. So I know owners like to get started. I know that when we're looking at plans initially and they don't have any stamp or the owner's trying to figure out funding, I get that. But when we build it without an approved set, that gets quite crazy. Here's an example of something we screwed up. We built this custom end wall for Virginia Construction Company down in Spotsylvania County. It's right off Route 1 and 95. This is corrugated metal coming in at a skew. We built the holes for concrete pipe. We got approved submittal, but at the end of the day, even though they approved it, we don't have a leg to stand on. We're the expert. We should have built the holes for corrugated metal, which are smaller. Concrete pipe, the wall thickness on a 60-inch is 6-inch wall, so 72-inch OD. Well, corrugated metal, 60-inch corrugated metal, I don't know what the OD is on 16-inch corrugated metal, but it's much smaller. So the space they had to brick up and fill in was substantial. Luckily, VDOT let them do it. All that being said is, we're the expert. When we make a mistake, we stand behind it. We build what's right. So when it comes to submittals, we like to give you guys, when they're non-standard, we like to give you that, something like this. We still make mistakes, but on standard structures, you don't need a submittal. You can just have a regular boilerplate cut sheet. We can send to you, because we're gonna do it right. We're VDOT QA QC certified, self-certified. So we're the expert, and you call me anytime, help you out with any of the nuances on your project that you think might have a design issue or struggle. So I think that's it. Any questions? Thank you guys for your time.
So I get to clean up tonight as well. Just a few more slides. It'll only take a couple more hours. I'm sure you'll want to stick around a little longer. It's not that bad, really. And a lot of these slides touch on a lot of the comments and discussion points that we hit on throughout the first 3 sections. So some of the site considerations, some existing utility coordination, and then a little bit at the end for those folks that are more structural focused. Structural economy. Is it really economy when you're designing it? So we talked about equipment size. We talked about some of the access limitations. But understand whether those access limitations are both construction and the public. At the end of the day, as much as we don't want pedestrian access, every one of our jobs are faced with it. We have to deal with it somehow, some way. As Tom talked about, the depth in the excavation, the size of the excavations, where we're going to put all this material. At the end of the day, it's in the ground, and that's easy. But where do you put all of the storage, the stuff that you need to build the job along the way? Give us a laydown spot. It's not just the easement. ENS phasing and coordination with permanent elements. And that's a lot of what you've seen here up to this point, but a few more slides you're going to see here in a second. So phase 1 MOT plan. Looks pretty simple, right? Supposed to build this 36-inch water, running down the road, says I'm going to do it under flagging operation. Seems straightforward. No problems, right? Well, there's some gas easements up here, some utilities, some storm we're going to put in at the end of the day. Look a little closer. Those gas easements require jack and bore. They tell us this is your jack and bore pit. Anybody have any idea how big a jack and bore pit is? 14 foot wide, about 40 foot long. In this one, it's almost 30 feet deep in rock. Put them in the road. How am I doing that? Under a flagging operation. So I'm supposed to put traffic back on top of that pit every night, open it back up every morning, work for what? Maybe 2 or 3 hours if you're lucky, and close back up at the end of the night. It's not going to happen. It doesn't work that way. It would be unbelievably expensive to try to cover this hole with a roadworthy cover and build it, if it was doable. On top of that, the job schedule was awarded in the fall, had a tie-in date of the water line before April 15th, and the job has to be complete before the following fall. So you don't have even another working season to work it. So you're forced to work in the winter. No steel plates in the winter. So you're back to that can't build it situation. So as I was alluding to there, see the jacking pit, they drill at the scout. It was right. They had the right size. Engineer knew what he was doing. Just didn't coordinate between the water line guys' drawings and the MOT guys' drawings as to how they were going to accomplish it. The solution was to rephase the job on the other side of the road that gets widened anyways, had to be built first. So we could shove traffic off of us just enough to build that pit. So this highlights some of the issues that I talked about. Maintaining traffic, that phase 1 MOT only allowing flagging. You know, steel plates not being permitted during that construction season, the window that you had to build it. And at the end of the day, making it traffic worthy. Limited working hours. So on these sheets, I flipped through a series of them. Keep your eye on the red circle. So phase 1 E&S plan shows this temporary sediment trap. No big deal. Little stream right through here, some existing culverts at the top. Seems fairly straightforward. It's a linear project, roadway. We're widening the existing road. Okay. That red circle is in the same spot as where it was in the previous page. This is the phase 2 E&S. All of a sudden, and every roadway job's always this way. Phase 1 E&S shows your silt fence and a sediment trap. Phase 2 E&S, all of a sudden, all the storm drainage is in. Suddenly. It just happens overnight. And then we got boxes and stuff around the DIs. But how did we get there? We had to put the fill in, we had to put the pipe in, but all the fill in the pipe went in the sediment trap that you needed to keep the silt from leaving the job. So, on top of all that, there's this arch conspan right here. Got to get access down to that conspan. Just off the sheet is those existing culverts that you had to maintain that stream flow around the arch in that phase 1. And you limited the site constraints and the design so that I don't have enough room around this wing wall to get a temporary ditch of any kind for the stream. Same circle, same spot, a little different view. You see the phasing of the box or the arch, the storm drainage, contour lines, all fill. This is the phase 1 work plan. Should detour the roadway, taking traffic off of you. Then you look at the roadway sheet, and you bring it all around and you go, uh-oh, I got, this green line represents an existing sewer, but this dashed green line here, it's a new sewer, the relocated sewer. Get it around that arch. So the relocated sewer goes through the temporary sediment trap. It has to go in first before the arch can get built to move the stream around it. All these layers have to be coordinated. And it's all different jurisdictions, it's different disciplines, it's different engineers all working on one big plan at the end of the day. But everybody's got to come to the room and remember to look at each other's stuff and make sure it works together. It's not pointing fingers that, you know, you should have done this, you should have done that, we should have caught it. Nobody caught it. We figured it out when we got out in the field and we went, uh-oh, can't go there. So silt trap, all it had to do was just a little corner of temporary property right here would have solved that problem. And on top of that, we ended up flipping the box phasing to make the job buildable, so that those temporary, or the existing culverts became the temporary culverts. We worked the upstream and then the downstream instead of vice versa. So we didn't restrict ourselves in that corner, and we were able to get around it. So just a lot of constraints on the job that you gotta be familiar with. So this compares, you know, some of the issues and some of the other things that it created. So sediment trap, you're intending to hold water in it. You want to catch the silt. But that sediment trap sat underneath the roadway location at the end of the day. So we dumped a bunch of crappy soil, silt, in a hole, held it with water, let it soak into the ground, turn everything else around it junk. So now we created an undercut to build the road on top of it. So we rippled ourselves into more problems because of the location we chose for that sediment trap. Whenever we can, and whenever we have the property to do so, we'll shove those sediment traps out. Like Tom said, we rarely build them where you guys say we build them. But if we can find a way to make them smaller, to make them longer and narrower, different shapes, different sizes, they don't have to be the same cookie cutter, graphic that you can pull out of the file and slide in there. But they've got to be right. At the same time, you got to have the right controls in. Because if we don't put the right controls in, the silt fence is going to get overloaded. The check dams that we put in are going to get overloaded. And then all we're doing is washing stuff down the river. And we know how important E&S controls are these days with all the compliance, all the MS4. It's a hot topic, and it's important for all of us. Little different view, much smaller project. That's the entire job, by the way. This is the whole job. It's a little local road up in Great Falls. It was storm replacement. Bridge had gone out. They threw some temporary culverts in, temporary to keep the road open. And then ultimate repair was this job. Got a driveway here and a driveway here. Well, got an overhead utility from that pole to that pole with nothing in between, and a big sag. Those graphics there in blue represent a 330 to scale. They got all the pipe. We have to drive sheet pile for the abutment to protect the scour. How do you drive sheet pile underneath a utility? Not with a crane. Sure don't. So driving sheet pile now with a hoe. Little different specialty type work. Most sheet pile guys don't own a hoe. And then you go down, how am I setting those girders? These ended up being precast concrete, inverted T girders. Put them underneath a utility, I got less than 20 feet of clearance. And then I'm stuck with rigging that's yay tall. And a concrete element, if it was steel girders, no problem. You pick them from the center, they carry the load, sling them on out there, no big deal, fairly light. Concrete, it doesn't do so well in tension. Tends to break. You end up picking it from the ends. You got to pick it the same way it's going to be supported at the end of the day. But that makes your rigging real tall. At most, you're limited to 60 degrees coming out of most rigging on a concrete precast element. Otherwise, it puts too much stress on the element itself. So to make this whole thing work, we had to add a lifting beam, and press all of our rigging way down so we could get the crane in there, and we flat stick the girder out on over there. So, as I highlighted some of the clearance issues, the installation of the sheet pile, the specialty equipment it required, the girder for the crane, or the crane for the girders. In the entire time we worked in this tight, congested, itty-bitty little job, every operator had to have a spotter so that they could see both the spotter and that utility at all times. We couldn't rip it down. And then on top of that, we had to maintain access to those guys' driveways. If anybody knows anything about Great Falls, you don't have a bunch of people that are willing to give up their driveway and make a long walk to their house. They usually want to drive their really nice car all the way through your construction site. So, just some additional advanced planning that was done really well by the engineering team, because it was a bid build job, so we had no influence on design. Picked the job up from VDOT. But
during the design phase, they were either smart enough to know or at least wanted to give the option of a pump around. So we were able to pump that whole stream around, working in a completely dry area, not be in the wet, not have to have any specialty conditions. So that was great. It gave us a lot of flexibility, even in a year that was fairly wet that year. The structural design allowed for limited heavy equipment, but it did allow for it. We were able to get to the site. We were able to get down there. We were able to get our equipment there, even though it was tight once you got there. So, talked a little bit earlier in PJ's slide about clearances and utilities. So, this was a test pit in our plans, a 42-inch gas line. It's a big gas line. Yeah. This one's another one. I forget, this one's 30 inches or so. There's 5 of these along the corridor. Right above that green block, it's a storm run. It's supposed to have 2 foot of clear. It does. It was designed well. It's got this 2 foot of clearance for the pipe, the invert of the pipe. What was missed was the 3-inch pipe wall at a minimum. If I don't catch a bell in that spot, and I just get lucky. 6 inches or so bedding. So now my trench, plus or minus, I'm within 12 inches of the top of this pipe. Virginia, what's Virginia law? Anybody know? How close can I put my piece of equipment to a piece of pipe? 2 feet. So what that means is, technically speaking, the last foot of that trench, I'm hand digging. It's a pretty expensive pipe for, what amounts to be a whole stick of pipe. 42-inch gas, you got to find it first. That's normal. That's no big deal. But then you're hand digging 8 foot long for a foot deep in what I'm sure is not the most conducive material. It's not sand. It's rocky dirt. Pretty tough hand digging. So some of the issues it created, less than 2 foot of clearance from the trench. Not from the pipe. They had their ultimate 2 foot of clearance. Require a lot of stop digging, but things that were done well. They at least got the planning right. There was no direct conflict with the storm in the trench and the casing pipe. And they had a test pit that was accurate. They put the test pit in the right spot where the crossing was. Can't tell you how many times that the test pit's 25 feet up the run. 50 foot left, 30 foot right, whatever it might be, it's not where the crossing is. And then there's an assumption made that, maybe you got 2 test pits and you got 5 crossings in between. That the 2 test pits represent a straight line between the pipe. I hope it's that way. It might be close. But whenever possible, put your test pits where our facilities are going to cross, where our work's going to be, so we know exactly what we're coming across. Some other things to consider as you're designing. Bottom of the trench elevation versus top of utility. Not on this job, but in other jobs, I've had conditions where utility owner doesn't like that. Yeah, technically that 2 foot is clear to invert. Nah, I really don't like your pipe that close. I want something now special. I want some special backfill. I want some special cathodic protection plate, whatever it might be. Something to break that barrier between one facility and another. So, as I said earlier, everything has a thickness. In CAD, it's not always as well defined as a thickness. Test pits may not be exactly where they are, but in the zone where the mechanized equipment are allowed. Then structural efficiency versus economy. So, private job. Designer did a great job. Showed 3 different wall types. Detailed them well. And it would have been great for anybody that wanted a handset. Handset forms, maximum heights between the steps were about 7 feet. So it would have been very conducive to somebody that wanted to go in here and handset to the first cold joint, pour it. Handset to the second one, pour it again. And just work his way up the wall. One of the things the designer didn't consider is this bar here. It needed to be down, anchored in. It had to have a lap of some sort down into that lower segment. But there's really no way to support that bar. It's kind of just dangling off of one cross, one tied connection. So if you poured it that way, one lift at a time, you got a bar that's embedded, but while you're pouring that wet concrete, that bar sits there and does this, dangles back and forth as you vibrate the concrete and move it. So you have a hard time holding it without a template. What was changed through an RFI process after we were awarded the job, 3-foot wall at the bottom was poured that way. Established the cold joint. This rebar was stuck down in here, and there were some chairs off the backside to hold it. But it was cheaper and more economical to use a heavy crane, a heavy set form system, and pour a 14-foot tall wall. It was 2 foot thick. So all that rebar got adjusted. That single face rebar on both sides. Didn't have that step and that jog. Didn't have extra cold joints now. At the end of the day, they got a better product. Less cold joints to affect the chlorides, rot the rebar away over time. And they got a 2 foot thick wall where they structurally didn't need one. But if the designer wasn't willing to work with us, wanted to, take offense or whatever to us questioning the design and not have that partnership type atmosphere, the owner doesn't get the benefits of the better design, the better opportunity. And quite frankly, we spend a lot more money trying to build the wall in labor that nobody recoups at the end of the day. So, just the things to consider as you're designing. We see it a lot in caps, pier caps for bridges. You can create all these fun shapes at the bottom of a pier cap to economize the concrete. Well, that economy of concrete, the concrete's cheap. You economize the loading that gets into the column, sure, but the concrete is the cheapest part. The labor to build that form system just doubles, triples, quadruples. So consider the effort it takes you to detail it in CAD, all that extra line work that you have to do. Think about somebody having to do that in reverse out of forms or lumber or wood, metal forms, whatever it might be. All that's got to be created in reverse. So, less concrete, the designer assumed it would equal lower cost, and then the steps would increase the efficiency. On our side, the way we saw it, fewer man hours with lower cost. Concrete was cheap. Get another load out, no big deal. More concrete is a savings in efficiency. Fewer cold joints, you got better durability, and a more continuous rebar reduces the material, but it also reduces the installation cost. And they got a continuous piece of rebar all over the top. Anybody have any questions? And at this point, you open up to any one of us. Do you have any questions, comments, things you want to discuss?
How are you allowed to build over those massive gas lines without some serious input or restrictions from the gas company?
So on that job, the gas facility is inside of VDOT right-of-way. They're a guest on the right-of-way. They had to extend their casings out. They had to do some front-end work. But the entire time we are on site and working over top of those facilities, we have a dedicated babysitter. And that individual watches everything you do, wants to know everywhere you're going to be, and not only we cross it with that storm run above it, we also have a jack and bore with the water line that goes under it. So we're going to open up holes, and he's going to watch us cross his line. Yeah. It's fun.
Sure it was.
Good.
So I work in site review in Fairfax County, and we see plans where retaining walls are, they're lines in CAD, and they show up on plans, and they may or may not have a thickness, depending on the designer, how they're feeling that day. Footers have widths in reality, and for us, we sometimes have to ask this at the site review stage to verify constructability, at least to the extent that the limits of disturbance are realistic. Do you ever run into a similar problem in the field that walls don't have footers that allow you to be constructible in your limits?
Oh, sure. Yeah, I mean, a lot of times the walls that you saw there, as tall as they were, That's how deep we were underground. Those were actually completely buried walls. It was a dam retrofit for spillway. So it was underneath the beach, never going to be seen by anybody at the end of the day. It's completely buried element. But we're that deep in the ground. Tom showed you the excavation. That's a really big hole, especially when you got a footer that's 25 foot wide. Now you're, 70, 80 foot across the top. So yeah, we find a lot of occasions that dimensions either don't line up from sheet to sheet to sheet, or that it's just not possible to build it that way. Hopefully that answers your question.
Thank you.
Anybody else? Tom, PJ, you got anything you want to add?
I feel like I've complained enough tonight, so might not be able to get out of this room safely.
Well, I appreciate everybody's time. It was a joy on our side, and hopefully you guys take something out of it as well.
Thank you.
Thank you.
So we're gonna get these folks' contact points, and Becky will send it to you tomorrow. She can send you the slide deck. The challenge is it's gonna be too big to go through your server, so it's probably gonna come to you in pieces. Do people want the slide deck, or is this one not? Want it? Okay, so you're gonna get a series of emails, it's the only way it'll come through. Thank you all for attending.
Good to meet you too. Have a good day.
Thank you, Dad. It was great.
Thank you. That was good.
Got here early, didn't.
Got through the few crises.
Yeah, no worries.
Yeah,
I feel like I had a long list of things.
So is this guy
It was
is
one
not
of
even
those
signed
things
up.
also, well, if I get done it again, as soon as I said that, I was like, oh shit, I forgot to say this.
Well, they worked out about right on the timing of it.
City of Alexandria working in existing road I have existing storm pipes.
You're gonna be able to give that to Becky, so she can,
I mean,
they actually already have it.
the whole thing corrected now?
That's the whole
So they want this slide deck.
In the same.
But you're gonna have to break it up and send it.
Upsizing the
So
file.
they have printed copies.
No, but they want the electronic one.
Obviously, I have
I think we sent it to you in chunks, probably.
that we're gonna find when we dig those. But we gotta keep the existing system, the river.
Yeah, I know. I was trying to see, did they actually go to
Build a new 36-inch pipe. Can you build that?